Hello friends, welcome to my YouTube channel Techno Talk lecture series. The topic for today's discussion is actually we'll try to give the answer to this question: when can a soil develop plasticity? Actually, I have received this question from number of students during my classes and also from number of professionals while being part of some seminars. So I just thought of making this small presentation where the fundamental mechanism responsible for the development of plasticity in soils can be understood very well. And we'll try to discuss few related aspects, and we'll try to develop the say reasons for development of plasticity. Let us try to understand first what is plasticity. It is the ability of the soil to undergo deformation without cracking and without fracturing. This is very important. This generally happens with very fine grained soils when it comes in contact with water. A plastic soil can be molded into various shapes when it is wet or when even it is moist. And plasticity is considered as an important index property of fine grained soils, especially the clay soils. Index property means a kind of property which is indicative of certain other parameters, certain other engineering properties. Plasticity can be determined very easily performing a small duration test in the laboratory, but it can really give us some good idea about the behavioral aspects of the fine grained soils, and that is why it is the index property of fine grained soils. Say we made one statement here that the fine grained soils, when it is wet, it can be molded into various shapes. Now here what you are able to see that if a fine grained soil sample is mixed with a certain quantity of water, then it is possible to give different shapes. If you try to mold it with your hands, of course your hands will get dirty, but it is possible for you to give different shapes. You can give a shape of a ball here. You can even try to give different shapes as a sculpture. Here a person is attempting to give a shape of an animal. It can be even molded as a ball or as a thread, or even some say like Ganesh idol, or even in some say clay articles. Here we have to work with the wet soil, and we try to make attempt to mold or remold the wet clay. This is possible only with, say, wet clay. It will not be possible with sand. Then what is the reason behind this? Let's try to understand. First, let us understand the basic soil particles. Here on the screen, what you are able to see is a grain size scale indicating the various soil particles which are possible. And we'll also try to understand what are cohesive soils and what are non-cohesive soils on the basis of the particle size or the grain size. The grain size here is shown in millimeter, and there are, say, certain ranges given from 4.75 to 80 mm. It is the gravel particle. From 0.075 mm to 4.75 mm, the sand particles. 0.002 mm to 0.075, it is silt particle, and less than 0.002 mm particle size, these are the clay particles. This is on the basis of the Indian Standard Soil Classification guidelines. Now here the particles which are, say, more than 0.075 mm size, they are termed as coarse grained soils, and particles less than that 0.075 mm, these are termed as fine grained soils. And with respect to this size, 0.002 mm, the particles bigger than that are termed as cohesion-less soils or granular soils, and particles having size less than, say, 0.002 mm, they are termed as cohesive soils. Now, the plasticity that we are discussing, that is generally observed in cohesive soils only when these are wet. Now, what really happens in the cohesive soils or the clay soils, that we'll try to understand. When a soil can develop plasticity, if two requirements are fulfilled: one, the presence of clay minerals in the soil sample, and it is getting mixed with a dipolar liquid like water. Now, these two very important things are required, and these requirements must be fulfilled. It happens because when these two are met with, there is development of adsorbed water layer. Now, we'll try to understand this term also. What is adsorbed water layer and how it helps in development of plasticity? See here in the sketch, you can see, say, if you take, for example, there are two clay particles. The clay particles are carrying net negative charge as a result of isomorphous substitutions, and this negative charge is compensated by some cations which are located on the surface of the clay, and in the presence of water, these cations tend to diffuse away from the clay surface to form what is referred to as a double layer, and the cations attract the water molecule because of the dipolar character of the water molecule. Now, this is the double layer theory, wherein the water molecule is attracted towards the clay particle and it forms a very thin layer of water on the surface area of the clay particle. Now, consider the earlier situation when there was no adsorbed water, and if the clay surface is dry, then what will happen? Because the clay surface part, of the particles that is in contact with each other, there would be frictional resistance, and the clay particles will not be able to slide so easily. But if, because of the adsorbed water, the layer that is formed surrounding the surface, the contact is now between the two adsorbed water layers, and that actually reduces the frictional resistance between the particles. And because of this adsorbed water layer, the soil particles can slide and slip over each other, and so the movement is very easy. This is known as the plastic nature of the soil. The presence of adsorbed water is necessary to impart the plasticity characteristics to the soil. This is very important. Now, when the plasticity will not develop, see, we discussed about presence of clay mineral in the soil sample, and it should be mixed with a dipolar liquid like water. Now, suppose if you take one case where there is definitely presence of clay mineral in the soil, but it is mixed with a liquid which is not dipolar. Say, for example, kerosene. If you mix clay plus kerosene, there will be no formation of adsorbed water layer. It will not form, and so there will be no plasticity. That will not develop at all. This is one case. The other case is if you have a non-clay mineral. Say, for example, if you have sand particles, and if you crush the sand particles to very fine size, say clay size particles, this clay size particles are actually having a rock mineral, say quartz, and if the quartz is getting mixed with a dipolar liquid like water, then there is no adsorbed water formation, and so there will be no plasticity. So requirements here are two. One is the presence of a clay mineral like kaolinite or illite or montmorillonite. These clay minerals only will attract the water molecule, from the, say, dipolar liquid. It is because of the polarity of that liquid. And second requirement is the dipolar liquid that should be mixed with the clay particles. So we said in the earlier slide that if there is a clay mineral in the sample, and second, if the dipolar liquid is mixed, then only there is possibility of the plasticity to develop. Otherwise, it will not develop. And other thing that is very important to note, that the soil can exist in different physical states. In 1911, a Swedish agricultural engineer, Adsorbed, mentioned that the soil can exist in 4 physical states, mainly liquid limit, liquid state, plastic state, semi-solid state, and solid state. And the water contents at which the soil changes from one state to the other are known as the consistency limits or the Adsorbed limits. Now, if you take, for example, the physical states of the soils and the water contents at which the physical states are changing, that means liquid limit, plastic limit, and shrinkage limit, it is giving rise to these 4 physical states: liquid state, plastic state, semi-solid state, and brittle state. Now, plasticity can develop only during the plastic state, when the moisture of the soil is between this limit. That means it should be less than liquid limit of the soil, and it should be more than the plastic limit of the soil. If the water content of the soil is between this limit, that means it is in the plastic state, then only the plasticity will develop in the soils. So this is the range of the plasticity, where it can be molded or remolded with help of water. I hope you liked the contents of this video. Please like and share the content of this video. Subscribe by pressing the bell icon, and your suggestions are most welcome. Thank you.